12.4 examples of polyester. So remember, polyester means that there is C double bond O and O as the main structures in the polymer. COO COO in the polymer. So first point, they said synthetic polyester Terylene. Okay, what is this? Terylene is actually the polyester which is used in the clothes. Okay, clothes. So terylene you can spin into fibers, and then they are used to do light crease resistance clothing. That means after wash, no ironing required. The shirt, for example, it looks smooth all the time, so no need to iron one. So that kind of material is made from terylene. And next point, natural polyester. Natural polyester, we have fat. So this is more to biology, where that time, if you learn biology, you have to know fat is formed by fatty acid, which is carboxylic acid, and glycerol, which is alcohol. So they join up. Okay, the alcohol and the carboxylic acid join up, which means the fatty acid and the glycerol join up to form fat. Okay, so let's see terylene. Terylene is our main concern because this is synthetic polyester, right? So, which is under chemistry. The natural polyester is under biology. Okay, now let's see the monomers here. We have ethane 1,2-diol. Basically, it is 2 carbon with OH on both sides. It is alcohol with 2 OH, with OH on the left and OH on the right. And for another monomer, so you remember there have to be 2 different monomer, not like additions polymerization. It's just one type of monomer. This one have 2 different monomer that join up. So we have 1,4 benzene dicarboxylic acid. So why 1,4? 1,4 means, let's say this is carbon 1, so this is carbon 2, carbon 3, carbon 4. So carbon 1 and 4 is linked to the carboxylic acid. Okay. So when this polymer want to join up, right? So basically, they just remove hydrogen and hydroxides. They remove H2O, okay? And then they join up. And this is the structures. Okay, so after removing the water, they join up to form this structure, and this structure is called ester. So used for spinning into fibers to form the crease resistance clothing. Okay, so now let's move on. 12.5 examples of polyamides. So polyamides, as the name here, amide means CONH. These structures have to be there. Okay, so now we have synthetic polyamides. Example, nylon. So nylon is used in clothing or gunnysack. Or the tug of war, tug of war. The tug of war means the rope that they use is made of nylon. Okay, so these are the example where nylon is used. Kevlar. This is used in fire resistance. Fire resistant structure, fire resistant wall, for example, or reinforcement in car tire, or reinforcement in aircraft wings, or bulletproof vest wear by police. So these are made from Kevlar. Okay, so let's see nylon 66. Nylon 66. So first of all, we need to understand nylon 66. What is meant by 66 over here? Okay, so let's see the monomer first. So this is the monomer. This monomer is called hexane diioid acid. So hexane means they have 6 carbon. 1, 2, 3, 4, 5, 6. 6 carbon. So carboxylic acid on both sides of the molecule. Okay, so the other monomer is 1,6-diaminohexane. So again, hexane means 6 carbon. 1, 2, 3, 4, 5, 6. 6 carbon. So the first carbon is linked to NH2. So the NH2 here is called amino. Okay, so the other amino is stick to carbon number 6. So NH2 here. Okay, so nylon 66 basically means the first 6 come from hexane diioid acid with 6 carbon. Okay, with 6 carbon. This one have 6 carbon, right? The second 6 come from 1,6-diaminohexane, which has also 6 carbon. Okay, so now when they join up, how they join up basically, so it's just the carboxylic acid and the amine or the amino, they meet each other and then they remove H and OH. So imagine they remove H and OH. So remove OH and remove H. Then they found H2O, right? They found H2O, and after that, the remaining structures join up. CO join with the NH. Okay, so that is called the amide. Okay, now let's see the next part. So we have another type of nylon, which is called nylon 6. So this is nylon 6. Just now is nylon 6, 6. This 6 means what? Okay, this 6 means the monomer used is Caprolactam, which is 6 carbon. 6 carbon. It just this monomer. It's not like nylon 66. There are 2 different monomer. The first one have 6 carbon, the second one also have 6 carbon. So that is why 66. And this one nylon 6, there is only one monomer which have 6 carbon. So then how they join up? Okay, let's see. The monomer have this structure, have this specific structures, which is like a ring shaped. Okay, so 1, 2, 3, 4, 5, 6, 7, something like heptagon. 7, 7 vertices. Okay. Now, first point, monomer contains both NH2 and COOH group. So where? Okay, maybe you feel like, oh, I can't see NH2COH, I can't see it because caprolactam look like this, right? So cannot see that. Okay, so then I have to put it here at the side here as explanations. Initially, it has COOH and C, 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 N, H, H. Initially, it has COOH and NH2. Okay, so there are like 1, 2, 3, 4, 5, 6, 6 carbon. One side is COOH, another side is NH2. So I purposely bend the structures. As you can see, I bend the structures. Okay. So if I'm not bending the structure, you should expect this is like a straight chain with COOH at one side and H2 at the other side. So that means if I don't bend the structure, right, it should be like this. It should be like C, 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 1, 2, 3, 4, 5, 6. Okay, so one side is NH2, the other side is COOH. So then the bend. Why they want to bend? Because they want to react on itself, So the bend because the amino, the NH2 here, want to react with the COOH. So that's why they bend. So when they bend, right, they want to react. How they react? Logically, they will react by removing H2O. So I use blue color to circle up this part. So they remove H2O, and then, of course, they form the structure. So they form these structures. So that's why monomer contain both NH2 and COOH group. It's like this and like that, and then they react and form the monomer, which is called caprolactam. Okay, so let's move on. Caprolactam is a cyclical compound. So as you can see, cyclical. And when heated at 260 degrees Celsius, the, the cycle breaks and polymerizes. Okay, so which means initially they are like this, and then when the temperature is hot enough, so the structures break down. As you can see, CO and H remain. So that means this CO and H will remain. So you should expect it to break here. To break here. And then they join with others. So this breaking point, the other side join with others also. Okay, so we should expect it to break somewhere around here. Okay, now they break and then they form the nylon 6. Okay, so now let's see properties of nylon. The first one, high tensile strength. High tensile strength. So what is that? Tensile. Okay, that means you can pull it. That's why it's used in tug of war, So because you can pull it and it never break one. Okay, so it's something like this. I try to draw out. High tensile strength. Let's say this is the nylon string. So you pull it by force in opposite direction. And not break. it doesn't break. So that shows it is high tensile strength. Okay, it is strong. It is strong. Okay, so why it is so strong? Why it doesn't break? Because hydrogen bond present between chains of polymers, the nitrogen and oxygen atoms with hydrogens. Okay, so you see the structure, right? You can easily see hydrogen bond is possible to be formed. As you can see here, NH. The H can form hydrogen bond with the O of another polymer. Let's say, like, imagine another polymer here, the O and the H, or the nitrogen with the H can also form hydrogen bond. Elasticity, single covalent bonds within polymer, chains are free to rotate. So that happens to single covalent bond. As you can see, these are single covalent bond, except here, here double bond. So all these part you can do rotations. Okay, so low density and branch chain, no gaps, hence very useful fiber in clothing industry. Okay, so we already discussed this. Okay, we can use it to form clothes. Okay, for nylon. Now let's move on.